All right, welcome everyone. This is a video for the review of Lab 5, which is maximal oxygen consumption measurement, protocol and criteria evaluation. So my goal in this video is to go through the review points on the lab and relate that to some PowerPoint slides and prepare you for the quiz upcoming on Lab 5. So first of all, review point number 1, gaining knowledge about the errors associated with maximal testing. Now, there theoretically is no error with max testing. I would say that for this, what we want to really make sure that we've done is calibrated the cart properly, right? So we've talked about that. We will potentially ask you to calibrate the metabolic cart for the quiz. So it is important to calibrate the gas and the flow meter properly before every test. Now, ideally, even if you're doing multiple tests in a day, you would still calibrate it after every or before every test. So that is essentially the best way to minimize the error associated with maximal testing. Also, making sure you're following your test protocols properly, making sure there is no air leakage. Like we had an issue in lab the other day where the mouthpiece that we used for a given student was too little. So as the test was going on, that mouthpiece was kind of falling out of her mouth, and then some air was escaping out of the sides of her mouth. And I saw this visually with her VO2 would drop really low, and then she would adjust the mask, get the mouthpiece in her mouth, it would come back, the VO2 would come back up, right? So that's just another example of just making sure that during the test you're monitoring what is happening. The computer data stream is kind of predictable in a lot of ways. So if you see something that is happening that is out of the ordinary, that could be a reason to check the metabolic cart, check what's happening with the subject, and make sure that everything is still attached and functioning properly, okay? Point number 2, know why GXTs are used for maximal testing. Let's just first kind of jump to the PowerPoint and talk about what a graded exercise test is. So this is the best picture that we like to use. It explains what it is. Essentially, with a graded exercise test, we have a series of stages. Each stage has a predetermined duration. So in this example, these stages are 3 minutes in duration. The duration varies based upon the test protocol you're using. And then at each stage, the intensity gets progressively more difficult, right? So in this example, the first stage is very easy. Usually that's the case with most protocols. During the first stage, you want the subject to settle in to a nice steady state, feel comfortable. And then from that point on, we're going to progressively increase their VO2 in a linear fashion. Ideally, they achieve a steady state at each stage, although that is not always going to be the case. So we're trying to slowly ramp up their aerobic metabolic rate, and then eventually they will go anaerobic once they cross the lactate threshold and then get to their maximal oxygen uptake, okay? The duration of the test should be somewhere between 8 to 12 minutes. If it's too long, then you have muscle fatigue that contributes to the failing of the test or the end of the test. And if it's too short, the subject goes anaerobic too quickly. Like if the intensity is too high early, the subject goes anaerobic too quickly, you're not really going to actually truly measure their aerobic energy production, okay? Let's go to point number 3, understand the reasons to stop an exercise test. Now we do have a slide for that one. Let me just scroll ahead and find that. So listed here, a lot of these are more cardiovascular related symptoms. So in our lab setting, these are not typically things we're concerned with, right? We're not measuring blood pressure during our testing. We're not going to be able to necessarily see instances of these symptoms here. However, we should be monitoring heart rate, and it should be increasing in a linear fashion. If it is not increasing, or if it is increasing too rapidly, we should pay more attention to the subject and either slow down, speed up, or potentially stop, right? We're not measuring heart rhythm typically during a test, so that's not going to be something we're going to be measuring in our lab. Of course, there is going to be manifestations of fatigue, but we want to pay attention to those, right? There are times where we might, as administrators, intervene and stop the test before the subject requests to stop, to make sure that the subject doesn't collapse or something bad like that happens. So although we do honor the subject's request to stop, we continue to cheer for them to keep going, but when they want to stop, the test is over. But we, again, may have to step in and intervene if we see some manifestations of severe fatigue, such as inability to stay up near the front of the treadmill. If they're consistently drifting to the back of the belt, then we might want to intervene and stop the test prior to them kind of going off the back of the belt, obviously. Okay. Lastly, then if the equipment fails, that could be a reason why we would terminate the test at that point as well. Okay. All right. So going back to point number 4, the ability to administer the test. So that kind of goes to the calibration. In our case, in our lab, the building of the face mask. So as you know, those are things that you are expected to know how to do. So make sure you're practicing the car calibration. You feel comfortable with that. The face mask, I feel like we've built those many times. We've already actually been quizzed on that once. So you should have a pretty good feel for that. The next thing is, the protocol. So before the protocol begins, we should collect some anthropometric data on our subjects. We'll need their height and weight. We'll want to go ahead and calculate their age predicted max heart rate. We're going to measure their resting heart rate and their resting blood pressure. Make sure there are no contraindications to exercise testing based upon the blood pressure. We then allow the subject to warm up, either on the cycle or the treadmill. Usually 3 to 5 minutes is what I recommend. If we're doing a running test, we're going to have them sort of ramp up or slowly build over that period of time up to the speed that they're going to perform the test in. And we're going to help them figure that out, right? For the running test, they choose their running speed. We want to make sure it is appropriate. It's not too fast, not too slow. Usually the guidance we give is roughly your 5K mile pace. So if you're going to run 3 miles, how fast is your mile pace? That's the speed we usually kind of use as our starting point to help figure out what the speed is going to be for the test. Okay. Now, after the test is over, that's kind of what this bullet point is jumping to now. We're going to determine if there is a VO2 max or a VO2 peak has been achieved. So we did review that in lab, but let's find the slides where that is discussed. It's right here, actually. So visually, this is what a max would look like. A max shows evidence of a plateau where the VO2 fails to increase despite increases in workload, where a VO2 peak is shown here, where there is not a visible plateau. Now, as we showed in lab, the data will never be as pretty as this, so we have to quantify the data somehow to see if there's a measurable plateau. The way we quantify the data is by looking at finding the high value, first of all, and then looking at 2 values above that, 2 values below, and what we want to find are 3 consecutive bits of data, and of those 3, 1 has to be the high value, and seeing if there's a difference of less than 2.1 ml per kg per minute between the low and the high value. If the difference is less than 2.1, that is quantifiably a plateau. So we would then call that a VO2 max. If the difference is greater than 2.1 between the highest value and the lowest value in that range, then that is going to be evidence of a VO2 peak. Okay, so there was not a plateau quantifiably observed in that instance. We did practice this in lab, and we will do it again when we do the lactate threshold test, etc. So this is something that I can talk through on a video, but really it's better to just do it in person in class, which of course we will do multiple times. Okay, but again, that threshold number we're looking for is that 2.1 difference. If it's less than that, it's a plateau, which means it's a VO2 max. If it's greater than that, there is no plateau, which we would call that then a VO2 peak. All right, next. All right, so what are we measuring during testing? Typically, we're going to record heart rate and RPE at the end of every stage. Those are going to be separate variables we will observe and record. Then from the computer, we're going to get other variables. We'll record the VO2 every stage, the VE, which is the volume of expired air, the RER, and there are some other variables, etc. we'll measure. The two that kind of stand apart are heart rate, RPE, and then the computer-based variables are the ones that I just listed there. Usually, you get heart rate and RPE the last 15 seconds of every stage, and then once that has been recorded and the next stage has begun, then you could record your computer-based variables. Those update every 30 seconds. So when in class, I like to wait until they update before I call them out to class. Now, this bullet point is a little bit redundant from this one, so we can skip that one. Okay, test validation. Now this semester we did add the validation protocol that we did with our subject. So if we jump to this slide, the way that we would conduct that verification bout is described here. So be able to describe this to me. So once the test is over, we do a 10-minute recovery walk. After that, we slowly increase the intensity of the exercise session over the course of 2 minutes back to our ending intensity that we finished the test with. They then perform that intensity for 1 minute. After that 1 minute is up, we then bump up the grade by an additional 2.5% and see if we can make it for 2 minutes. And we try to observe a plateau there, okay? That would validate what we saw in the initial test. Outside of that, the secondary validation criteria are all listed here. So there are 4. Ideally, we achieve 3 out of 4. If we achieve 3 out of the 4 criteria, then we have validated our test. Okay, 3 out of 4 or 4 out of 4 obviously would validate. 1 or 2 out of 4 would force us to say the test is not valid. The reason we have to do this is because since this test is a volitional fatigue, the subject stops when they want to stop. How do we know they actually achieve their VO2 max? We don't. So we look for these markers to say, okay, if they achieve 3 out of these 4 things, and it looks like this person did actually reach their VO2 max, so we validate the test. Okay, so the 4 things within 10 of the age predicted max heart rate. This is why we calculate the age predicted max heart rate to make sure we can use this validation criteria. If lactate is measured, it should be greater than 8 to 10 millimoles per liter at the end of the test or at any time during the test. RER value greater than 1.1, and then rating of perceived exertion greater than 17. So 18, 19, or 20. Okay. All right. So the interpretation of measurements, we've kind of hinted at that this whole time. Strength and weaknesses of protocols. All right, we have less than 3 minutes on our timer, so let me just jump to that. So the protocols, let's see. Here are some. A-strand, this is the one we do in class. So the advantages and disadvantages are listed here. Be able to describe how to perform this. So tell me, first stage is 3 minutes. Every stage after that is 2 minutes. We're going to keep the speed constant, increase the treadmill gain by 2% every stage. What values do we collect at the end of every stage? Heart rate, RP. We already talked about that. So generally know how to perform the protocol. Here's the Costal-Fox. We don't do this one in class, but just know there's an alternative running protocol that's out there, advantages and disadvantages. The traditional Bruce treadmill protocol, this one is typically done with clinical exercise testing. When we do an EKG lab, we will have a subject perform the Bruce treadmill protocol. This is a walking-based protocol. I don't have the cycling protocol on here because we will do that when we do VO2 or lactate threshold testing. Let me just kind of run through. I do want to take a minute to talk about the RER value. So the RER, respiratory exchange ratio, that is calculated by looking at the amount of CO2 produced over the amount of O2 consumed. That number can be derived, or that number is derived and can give us insight into the fuel mix the person is burning at any given moment, okay? Because fat and carbohydrate have different amounts of carbon and oxygen in them, as it is shown here. So carbohydrate has consumes an even 6 O2 to 6 CO2 produced, giving us a value of, or a ratio of 1.0. So when somebody's burning pure carbohydrates, their RER is 1.0. Fat has many more hydrogens, leading to a different ratio of oxygen to CO2, 23 over 16, or sorry, 16 over 23. That gives us a ratio of 0.70. So when somebody is burning pure fat, their RER is 0.70. If they're burning an even 50-50 fuel mix, the ratio is 0.85. Those are the 3 that I usually ask students to remember. So we monitor this during the test. Early in the test, they should be burning more of a even fuel mix. As the test proceeds and the intensity rises, then they should eventually progress to burning pure carbohydrate. Usually this occurs in RER 1.0 around the lactate threshold, and then fatigue is going to hit pretty soon after that. Okay, my video timer is about up, so that's the end for this video. Good luck on this quiz. Goodbye.